Okay, will you tell us about your project that you have on houses A through D?
Okay. Well, we're Project 2, and it's Logan, Madison, and Morgan. Okay, it says, Dear Tennessee Department of Energy, to whoever it may concern, our data team has been working for 2 weeks straight on 4 particular houses, figuring the cost of electricity it takes for each house. We've also figured up which house uses the most electricity as well as which one uses the least. Here are our findings.
This is our graph showing the comparison between all the houses and the weekly cost of each one. Our math led us to the conclusion that house C is the best house to build. There's our graph showing the house A is blue, house B is orange, house C is yellow, and house D is green. Here's houses A through D, the cost for 1 month of the electricity. Here's house A. The house A formula is how we got the weekly cost. We use the formula 0.07x times 842.4 divided by 2.873 plus 4. House B, here's the cost for a month. We use the formula 0.08x times 3816.576 divided by 4.773. House C, we use the formula 0.05x times 14.688 divided by 0.041 plus 29. House D, we use the formula 0.06x times 39132.48 divided by 11.521 plus 18. Here's the houses in order from least to greatest. House C we found was the least expensive. House A followed. House B followed. House D was the last. Here is the X's we plugged in to find our information of the weekly cost. To find the cost of electricity used was 730 hours for a month. We did a quarter of 730 for 1 week, then a half of 730 for the second week, and 3/4 of 730 for the third week, and finally 730 for the last week to find the cost of electricity for 1 month. So we plugged them in 4 times to find the monthly cost.
Okay, thank you. This is it's very well written, and I can see from your graphs. Can you go back to the bar graph? I can see from your bar graphs you have all the information on one slide. It's labeled very clearly for me. I noticed in the housing packets that were given to you guys as well as to us that you have on inductors and capacitors, it's listed to have numbers that have an I behind it, like 65I and 25I. How do you use the I's in your equations to find out on the other slides that I saw that you had equations for each one? How do you use those I's in your formulas?
To find electricity, you don't need heat, and the heat is the I, so you just cut out the number that is in front of the I and leave it out of the equation to find the cost for electricity.
Okay, so technically, as a consumer of electricity, I'm not in these graphs having to pay for the heat that's being produced. Is that right?
Correct.
Okay. And was it hard being the math people that you guys are? Was it hard working with the I's? What did you have to do to work with those imaginary numbers in your formulas?
Well, we had to. Sometimes they were squared, sometimes they weren't. If they were squared, it took them out, and if they weren't squared, it left them in there.
Okay. So when something is squared, what does it turn into?
It turns into -1.
All right. And was it like combining like terms? What did you have to do in those formulas?
Whatever number was in front of the squared I changed to a negative or a positive. because you multiplied it times the I, which turned to a negative 1.
Awesome, thank you. Okay, and then I know that we had phase 1 and phase 2 portions, which I can definitely see. This is phase 2, which is the completion of our graphs and etc. How did you go from formulas and just the inductors and the capacitors? What were your steps to get from phase 1 to phase 2?
Say that again.
No, that's okay. We had some houses that just had numbers with resistors, inductors, and capacitors. And you took that information and stepped us all the way to these graphs with great representations with equations. Can you tell me how you went from phase 1 to phase 2?
Okay, we use the formula 1 over RT equals 1 over R1 plus 1 over R2 to find our 1 over RT. Then we used 1 over RT to find power, and to find power it was voltage times resistance, and we found power, and then we plugged it all in to the equation, and it gave us how much the cost would be for a month.
Excellent, thank you. These are good recommendations. We'll definitely keep these in mind when we're building these houses. Thank you very much, guys.